In this examples, we're going to look at how to solve for square roots. And I'll remind you that we're really following just the same exact steps that you learned in Algebra 1 until the final step when you take a square root. So in the first number 1 problem, we have 3a squared plus 6 equals 18. So our first step will be the opposite move. We're trying to get the squared variable, which is over here, by itself. So the first step should be to isolate it by taking the negative 6, moving it to the other side. Whatever we do to one side, we have to do to the other side. So we're doing what we call the opposite move. Okay. And now we're bringing things down. So we will have 3a squared equals 18 minus 6 is 12. Okay, so now at this point we're ready to either multiply or divide, and since it's 3 times a squared, we will be dividing. So we divide both sides by 3. This is a common step in Algebra 1. Opposite move, then divide. Okay, so that was our moves. We're moving along here, looking to solve, and we end up with a squared equals 4. And this is our new step. We take the square root of both sides. Whoops, that's a terrible both. Let's write that again. Both sides. And remember, when you do that, you will have 2 answers. Always 2 answers when you're taking square roots. You will have a positive answer and a negative answer. So just remember that you need to always have 2 answers, positive and negative, and you put them in brackets because this is not an X and a Y answer. It's not an ordered pair. So starting with where we are now, a squared equals 4, I will take the square root of both sides. And down here, I will put my plus minus because I'm ready. Plus minus 2. And that a is equal to plus minus 2, which means that a is equal to, and we use brackets, positive 2 and negative 2. And we are done with that problem. Solving by taking square roots. Done. Not too difficult. Let's look at another example. Here we have a different situation, but we follow the same steps. As before, we're going to do that opposite move as our first step. That's the same. Okay, so I'm going to subtract the 8 to isolate the n squared. So I'm going to draw my line underneath. And remember, I'm trying to isolate the variable n squared because that's what I'm solving for. So it becomes 49n squared equals 12 minus 8 is 4. Now I'm ready to divide. So I do that. I set up to divide. 49 divided by 49, 4 divided by 49. And I noticed right away that 4 is not divisible by 49 without creating a decimal answer. Well, I don't want to do that. But I also noticed that the number 4 and the number 49 are both perfect square numbers. So this time I'm going to take the square root of the numerator and the denominator separately. So I'm going to create a fraction answer. So you do this whenever you see that it does not divide evenly. You do not want to square root a number that's a decimal if you don't have to. Okay, so I will do that. I'm going to write that step separately so you can see it a little more clearly. So you notice that you have to do this because 4 is not divisible by 49. So I'm going to square root the top and square root the bottom and also square root the n squared. So the square root of n to the second power is one group of n. And now I'm going to have my plus or minus answers. The square root of 4 is 2. The square root of 49 is 7. So if I was looking for my answers to be shown as 2 separate numbers, it would be n equals positive 2 over 7, comma, n equals negative 2 over 7. And I'm done. So again, this is just a little twist on solving for square roots when it comes out to be a fraction.